Welcome back to the third episode of Checkpoint's HTTPS inspection enhancements in the new R82 software release. In this episode, we will talk about what client and server-side errors are and show the new flexibility Checkpoint allows its customers in enabling them to make their own choice as to managing the flow of traffic through the network and so making allowances to different types of networks and security objectives. There are different causes of client and server-side errors. There are cipher mismatches, certificate errors, any number of the actual IP network issues on either the source or the destination, many opportunities for connectivity to drop and disrupt business. Checkpoint has gone the farthest in painstakingly differentiating between the root causes and dealing with each use case in the appropriate way to give your organization the tools to configure the network traffic according to its objectives. So you can prioritize connectivity, but pay attention. You need to choose it as it's not the default. The default of dealing with such issues would be fail close, meaning the suspicious traffic will be blocked. We will start with client-side errors. This refers to any issues that occur due to errors that originate on the user side. In the new Checkpoint software release, it is possible to configure HTTPS traffic inspection to deal with such errors in either fail-close or fail-open mode. Let's see how it looks in the configuration windows and the impact that each option has on the outcome. To configure the client-side fail mode, make sure you are connected to the correct firewall object in your Smart Console dashboard. Choose the HTTPS inspection tab on the left and click on the Edit button. In the settings window that opens, change the configuration of the client-side option to fail close and install the policy. Now let's see what will be the impact on the traffic going through the security gateway from the user experience point of view, and on the back end, which logs do we have to investigate it. After we install the policy, I will open a Microsoft Store and try to download a standard known application, LinkedIn for example. Microsoft Store shows an error. Again, it can be because of a certificate issue, cipher mismatch, or because of incompatible software. The result is that the application download fails. Even clicking retry doesn't help. The application won't load. But let's consider a case in which the security admins can trust the traffic expected in their organization's network, and they want to ensure continuity and availability. To this end, they can change the policy to allow these connections to go through. Going back to the HTTPS settings and changing the client-side option to fail open, so we can try this action again. Make sure to install the policy after each change. Now I'll return to the browser and Microsoft Store and try to download LinkedIn application again. This time, the download process has started and there is no issue or error message. After the application will be installed, I will go ahead and launch it. We will get an error message regarding the certificate as the security gateway still does not recognize it, but if you press Advance and continue to this website or refresh the page, the application will load because the firewall saved the connection in its cache and it's operating under the fail open directive. In this example, we demonstrated the new software's ability to enable security and connectivity by recognizing the fact that organizations may have different priorities and give the security admins the ability to offer a solution to ensure it. In the next example, we will go to the other possibility, the server-side errors. In this case, the client is all up to date, but the server it is trying to connect to is the one with the issues. We'll go back to the HTTPS inspection settings window and this time change the configuration of server-side to fail close mode and install the policy. As we did with the client side, we will observe the user experience on one hand and the backend logs that are available to us to understand what happened. After the policy has finished installation, I will open the browser and use a special website called badssl.com to simulate a bad connection and choose a simulation of a site with a weak cipher suite and get a site unreachable error message. Let's try another one and get an HTTP 400 bad request error code. Now that we've created some traffic, let's go back to the logs and see how those actions were recorded. I will choose the Logs and Events tab again and look for the relevant log. It is easy to spot bad connections if we look for the dropped connection status, and when we open the log and go to the HTTPS inspection section, we can get the details of why that connection was dropped. As you can see, the log is quite comprehensive and clear. In the action described as an error, the fail reason is a server-side issue, and the drop reason resulting is the fail close mode. On our second simulation example, we can see the 400 error occurred due to a certificate mismatch, so that the traffic got an alert status and the log shows that it was inspected and detailed information about it. As with the client-side issue, the improved feature enables the security team to make a specific decision regarding this type of errors and ensure undisrupted communication by configuring the firewall to a fail-open operation mode. Back at our browser, we will repeat the experiment and check the logs again, but this time expecting the traffic to go through thanks to the change in configuration. Searching the logs, this time the status we are searching for is bypassed. This time, the logs show that the connection wasn't dropped but bypassed, and in the HTTPS inspection section, we get the same set of information markers. Though the action is classified as an error, the bypass reason is a fail-open mode to clarify that this was a conscious choice, not an oversight, and the fail reason gives the full detailed summary of what is on the server side caused the need to bypass it. So connectivity was sustained and the log created with the suitable alerts for security admins to be able to track and ensure it had been the correct decision are in place, ensuring proper responses and network robustness. This brings us to the end of this episode. Thank you for watching it. The next episode will be the last in this series and explore the last option in Check Point's HTTPS inspection configuration, which ensures seamless connectivity despite traffic overload, the bypass underload feature. So stay tuned and see you soon.